over 80 research articles with over 28,000 plus citations in his career, including 2 patents. He has been the principal investigator for multiple large-scale projects, including one for DRDO, and has been awarded several research grants. We welcome you, sir, to discuss the challenges in ink formulation for conductive nanomaterials in the diverse energy storage applications. Over to you, sir.
Thanks, Mithul, for your nice introductions. And thanks for the invitations and giving this opportunity to talk with the young people. So directly I'm talking, this is what my title of the today talk. I hope my slide is visible. Is it visible? No? Mithul, slides are visible,
Uh,
no?
no, sir, your Teams is visible.
Teams is visible. Are you able to see now?
No, sir. Um, 1 second, sir.
So maybe stop sharing and start sharing again. Yeah.
Yeah,
Yeah. Screen. This one, no? Screen.
yes, sir. Now it's visible.
Now it's visible, no? Yeah, fine. Yeah, this is what my title. The ink formulation challenges for conductive nanomaterial for energy storage applications. So I'm going to address today talk what are the different method of printing is and what is our struggle to face to preparing the ink formulations, and of course some 3 to 4 different applications we are going to discuss. And in our lab, what we did, what we have fabricated the device and what we have formulated the ink, those things also I'm going to show in the end of the presentations. So might be because as I knew that Saturday 6:30 it is very odd time, and of course other events it's parallel, it's running on solar cell based vehicle running. So students are limited. So I'm not going to take more than 45 minutes. So 45 minutes I'm going to discuss, another 5 to 10 minutes question and answer. So it might be a very short and short presentations for you. And you see that what is the challenges involved in the ink formulations and why it is important conductive ink preparations. If you see that in the year particularly 1990 to 2000s, there are many artists will be there for writing the boards and flex. Now all the flex and board it's replaced by the roll to roll printing only. So everywhere, even any of the advertisement, if you see outside, they are preparing flex only they are keeping. No one, the artists are not there. Artists are turned to some other field and they went for some other fields. So basically, printing it has a huge role. Either if you go for any kind of textile shops, whatever they are showing the bags, it's printed only. And there are different varieties of printing it's available, and each and every cases, and of course there it doesn't require the conductive ink. And we are going to focus on conductive ink. The reason is our aim is to prepare the storage devices and a different kind of sensor we want to prepare it. So for that reasons, we got to achieve the conductive one. So what is the challenges to prepare the ink, right? Consistency and viscosity, right? That is one of the, because if it is a very high viscosity, then the ink it doesn't flow to one place to another place, and there will be a no uniform distributions and value on to print uniform distribution. It won't be there. So, what kind of substrate you are going to print with respect to you require the consistent viscosity it's required, then only the dispersity of the flexible substrate or any kind of substrate it will be proper. Then uniformity of the printing might take place. So that is a big challenge to prepare the ink. And of course, right, the majority of the material, if you take that means maximum it becomes a black color material. The black color material, if you print, right, particularly for the sensor, it's not a matter because color it doesn't matter. We need a quality of the conductivity of the material. But if you go for printing any bags, color is better. That means what kind of dye you are going to prepare. So with respect to how you can attract, the bag should be attractive one when selling the product. Then only people able to buy, or even after 10 years also they can able to identify it might be purchased for this song. So that means color is very, very important and should be attractive, and opacity and coverage. And of course, drying time, right? And tomorrow I want to 1,000 bag, for example, right? So drying should be a very proper, and after drying should not come out from the bag, or should not any kind of sense, or if you did also. So adolescence, how the adolescence survey, because in sometimes if you came to know that if you buy the bag, the ink, it may be touches in your finger itself. Right? That kind means no one prepared those type of bag. So that and all we got to address that. And the compatibilities, right? That is very, very important. So the top should be compatibility with you. Then only you can able to understand that the way of product where you are going to deliver, that should be compatibility with each other. Then only we can able to maintain that. And of course, environmental considerations. Suppose you are using a dye, right? Degradations of the dye, it will take a longer time. So that case, the preparing the ink, it will be a questionable. And a special effect, fluorescence material, phosphorescence materials, and of course security, right? Those security means it should be invisible. They can't able to identify. So whenever the thief is coming touching the particular face, he can the fingerprint it might be captured in the. So that may be special kind of effective to do that. And of course storage and the shelf life. Finally, whatever you did, you got to clean up that particular surface. Of course, in the ink formulations, it is a big challenge for clean upping the material. The lab will be in the bad conditions only. So the first, there are three kind of printing we are going to discuss. First one is the screen printing and the inkjet printing, roll to roll printing. The majority of the cases in our lab, we are focusing on the screen printing. So basically, how it going to prepare means we are going to. I am going to show the formulations of the ink later stage in the humidity sensor preparations. So basically, we require the mess. In that mess, what we are going to, what we have prepared the ink, you are going to apply. So you are going to design a particular design. You are going to do that, right? Where you see that at this slide, it might be helpful to identify. So this is what the electrode I have did, right? These electrodes, in a particular surface only, I want to coat my conductive ink. So this design, I am going to do it in the mesh. Thereafter, I am going to apply the ink, right? Using the skews, I am going to apply the ink. So the exactly that particular surface only, the material it is going to print. And of course, after that, we got to dry. And to bring that, first we bring the connectivity, what you are going to do is over that you are going to paste a silver electrode, silver paste. Then for the connectivity, we are going to give a buttons. So this button only going to give a connectivity to find the resistance, capacitance, whatever it may be. So basically screen printing, it's a transfer of the ink to the substrate on the mesh screen and leaving the desired image or design on the surface. And you can take any kind of paper, fabric, glass, and metal. Here, the idea behind the what is the challenges to preparing the screen printing ink means dispersibilities and should be dried properly, right? And it has to follow, it has to pass through the mesh. If it is blocked in the mesh, right, then you can't able to get a proper design of the printing. That is a problem we used to face. Sometimes we used to prepare the ink, but it doesn't pass through the mesh means the whatever you put, even if you reach a very good conductivity also, then it is waste only, we can't able to do. So that means you got particle size, right? What is the particle size of the ink? What kind of material you have used? That is very, very important. Then only it might be passed through the mesh and you can able to print it. So this is what the screen printing process. first you got to prepare the screen, and the screen design you got to create, and then you got to keep it in the sun, right, for the exposure and developing the design. Then you can prepare the ink, then you can apply the ink over the screen and fuse this. Then printing it maybe takes place there. Finally, maybe get a drying and a curing. You can do that. That's what the screen printing technique. The next one is inkjet printing. So you can see screen printing technique or maximum you can do for the 10 to 5 to 10 device at a time. But if you want to give for a more than 100 device, if you want to fabricate, right? The next method is inkjet printing. Here, the preparing ink, we can be able to prepare the ink. But the problem is, right, where the problem it comes, you see that in the piezoelectric actuator, the proper droplet in the nozzle, proper droplet has to be formed. Then where you have keep it in the printed pattern, exactly it has to fall down. So this is in fact we have trying for more than 3 years. Still, we couldn't able to achieve that. The reason is either whatever the prepare the ink directly pour to the substrate, we couldn't able to proper the pattern. Even if you after pattern also, right? There is uniformity. It's a big questionable here. So if there is a uniform, particularly in the electrochemical chemical studies, if there is no uniformity, your output of the device is going to become problematic. So piezoelectric actuator, it will be there. What is the ink you have formulated that you are going to keep it in the nozzle? Then the droplet, it has to be give a proper pattern in your substrate. Right, that's what it's happened. We have, in fact, we have commercially prepared ink in the Japan also. We have tried that. Still, we couldn't able to get a proper droplet and proper pattern in the ink is printing. Hope we are trying with some other method. Another 1 or 2 months, we may get succeeded. So the problem is ink delivery. So it has to form in the droplet and then in the fast way you have to print it. Right? It look like a droplet, but it has to be nozzle properly. It has to come to your pattern. Then only you can able to develop the printing. And then image processing, then printing processes has been taken place. So based on your application, color missing you got to do, then drying you got to do that. This is what in the inkjet printing process. The next one is roll to roll printing. Right? Suppose you are flex you are preparing. The best example is right, either in the marriage function or birthday functions. Right? They used to keep a flex everywhere. Now, earlier cases when I'm there in childhood days, we used to see the poster and go to school. Right now, there is the poster under it is not there. Right? Everything it is coming in the form of the flex one. If you see that flex, they are using the roll-to-roll printing process only. Either you can take a plastic print, paper, textile, or metal foil. The idea is we can't be able to do in the academic research under roll-to-roll printing. So this is what is going to happen in the roll-to-roll printing. So paper roll is going to there and the printing plate. So whatever you are going to do in the printing plate is going to happen. So the printing it might be going to come. So the cylinder rotates in contact with the substrate material, typically continuous roll of paper and excess ink is wiped off of the surface. This is what it's happening in the roll to roll printing. So where it is happening, where it might be helpful means wherever you require the bulk process, right? Here the bulk and the huge printing, particularly flex printing, advertisement purpose, we can able to do a printing process. And here also the preparing the ink and the country, how it has to be, there is a big challenges is there. And these all the three method, it having a good job opportunity, not only job opportunity, even the next level of research you can able to carry out any one of the process, right? And advantages here, since it's a roll-to-roll printing, high image quality you will get, and you will get a proper consistency in your roll-to-roll printing, and ability to reproduce a fine details and vibrant colors. And you may get a high volume printing and a fast production speed. It's possible to achieve in the roll-to-roll printing. And of course, in this is what three different printing normal majority it is happening. Of course, in addition to that, there are plenty of other method is there that we are not focusing. In our lab, what we have tried that only I have focused. We are fully working on a screen printing. We tried to develop the inkjet printing, but we couldn't able to succeed. We tried to go for roll to roll printing, but the installations of the instrument and other thing it becomes so expensive, so we couldn't continue that because it's a bulky method and you need a the big quality of the things that is not required for our academic and research work. That's why you couldn't go for roll to roll printing. So in our lab, what we did, so we have developed some flexible supercaps and a flexible sensor for our work. Those work we are going to discuss. And here, whatever the ink formulations, right? There are many, n number of people already they have prepared the ink and they have commercialized, and even inkjet printing also you can get a n number of people. The idea behind that, the first we have taken the PET substrate. In the PET substrate, we got a uniform printing, and that uniform printing that would then to give a proper connectivity to the current character and getting the proper redax peak of the energy storage material, it's a big challenge that we have achieved using our ink. So this is what our innovations. We have the first we have developed, particularly South India, we have developed a flexible micro super capacitor and a flexible humidity sensor and a flexible strain gas sensor. Gas sensor work recently we have started, and two MSc students are successfully synthesis and doing the gas sensor, ammonia gas sensing they are developing, and strain sensor also we have developed. So this is what our publications, and we have filed two different patents, particularly in flexible energy storage devices. One is flexible supercap, and recently we have filed one more patent also. And of course, it comes in the later stage when I am explaining. And three papers we have published in the material letters, all the papers with BTech students only, right? BTech students only, the first author, all the three papers. And so why we need a supercapacitors, particularly normally in the beginning of the days, right? Now only it's focus on the lithium-ion battery. Earlier they tried to use a lead-acid battery. Even if you see the internal combustion engine, now also they are using the lead-acid battery only to ignite the ICB engines. So that time, what happened when they taking the power from the battery? Huge power it will withdraw from the battery, so the engine kick up start it create the problem. So that time what they think, why can't we can make a hybrid with a supercapacitor? So initial power, whatever the power it might be give to kick off the engine, supercapacitor might helpful. And wherever you require the high power density, particularly for your missile applications, right? In Navy applications, missile application. That time, if you need a sudden pulse power, the supercapacitor can able to do that. Imagine that up to now, whatever the market is there, it is a not a flexible methods. We only develop the flexible supercapacitor to deliver the high power output. So based on your applications, we can able to use our supercapacitor anywhere else. And this is what we have fabricated in our device. And we have taken the PET substrate. First, we have pasted the silver ink, and what we have synthesized the ink, we have screen printed. Over that, we have kept the electrolyte and give a current character. You see that excellent screen print, excellent redax peak you can able to find out, right? 0 to 1 voltage in aqueous solutions. The entire process it has shown. First, silver current character we are doing. Then the require what we have synthesis material over that we have pasted. Everything it is a ink formulations only. Silver also we have optimized. We are preparing a screen printed ink. And what we have synthesis material also we are pasting over that. Then the ink, electrolyte, everything it's a self-dependent wrap from electrode to electrolyte. Either it might be a sensor or either it might be a flexible batteries. So if you come to our lab, either in the form of electrode material, electrolyte, everything you are going to synthesis, and of course fabrications, testing, right? So the student will get a full exposure, particularly these studies, right? From synthesis, characterizations, formulating the ink, after formulating the ink, screen printing, then fabricating the device. Not only after fabricating, now you can test your device, how much it's performing. The next level also we have reached, we have developed the two device, it's ready for commercializations. That device also we are going to show in the end of the presentations. Okay, so from beginning to the end of the product, it coming to the market. Up to that, we are doing the work, right? Either in the sensor, and of course now one more chemical engineering student fabricating the lithium-ion battery is synthesizing the cathode material. That cathode material is going to use for the normal lithium-ion batteries, and one more students we have planned to give for the flexible lithium-ion battery. Okay, so this is what the industrial applications of the supercapacitor. Either you can integrate with the solar cell or integrate with the thermoelectric generator and a gas sensor, right? Wherever you require the high power, that time you can integrate with this flexible supercap, right? So wherever you require the flexible substrate, this application, it's particularly we need a flexible substrate, means you can contact us, we can able to give a very high energy, yeah, very high power density supercapacitors. And these are the similar products we can able to find out, but all the things it is not there in India. India, we only preparing the flexible substrate, and this is a UK based industries and this is US based industries. And you see that this is what they have used. We are only using the flexible PET substrate. They are using other flexible substrate. Okay. And next, in the Indian market, these are the devices. No one is addressing the flexible substrate in the Indian market. And we are the first vendors to addressing and preparing the flexible supercap. And this is a comparisons of the Intel devices. And next one is humidity sensor. See, this is one of the important applications, particularly to quality of the agriculture product to check. You must know the humidity. Not only, for example, when we put in entrepreneurship, we have put a straw. That time when cashew nut industry manager has came, he told if you able to develop the humidity sensor, immediately I will tie up with all nearby cashew nut industries. We will take your products. So that's a device only we are going to show in the end of the presentations. Because the reason is to increase the weight of cashew nut, they might be farmer might able to get a good amount of money. So normally the find not for money to find out high content humidity or moisture in the agriculture product, humidity sensor is required. So basically, whatever the products is agriculture product is there, you can keep it in the sensor. You can keep it in our device, and it can able to show what is the humidity of the product. With respect to that, when you can put a seed in the agriculture field, when you can go for the cultivations, when you can able to sell it properly, with respect to your surrounding atmosphere, you can able to find out the humidity, and you can control your agriculture productions, and you can able to get a good amount of agriculture productions. So that's what we have developed. And this is basically here the same thing only. Silver we are going to coat. Over that, what we have synthesis material we are going to coat. And we are not going to keep any kind of electrolyte here. Whereas supercapacitor means we need a electrolyte. So that material you are going to connect to the your microcontroller. The microcontroller might able to monitor the resistance of your sensor. So whenever the moisture it fell down to your sensor, so with respect to that, the resistance of the sensor is going to vary. So based on the resistance is varying, we can able to monitor the humidity of the present environment. That's what basically its principle involved in that. And there are four type of humidity sensor is there. Basically, we are working on a resistivity base because capacity base means in between two material you got to keep a dielectric material. Dielectric material means a non-conductive substrate. And again, it might be vary the capacitor. That also we can able to prepare very easily. And optical thermal conductivity humidity sensor, it's basically with the light. So suppose the light you want to monitor with respect to light, if you want to find the humidity, you can able to do optical humidity sensor. Thermal conductivity humidity sensor, there suppose 1000 degrees Celsius is there. So there very high temperature is there. With respect to that high temperature, the conductivity it's going to vary. So what is the humidity? It's going to find out that you can able to find out. So those two applications now we are at present we are not concentrating. We are basically working on the resistivity humidity sensor. In of course we can able to do capacity humidity sensor also. So this is what the initially I told you how we can formulate the ink, right? So initially what we did, we have synthesized the tungsten oxide using inorganic precipitation method. To improve the conductivity, what we did, we add some small amount of the graphite, not only improving the conductivity, and of course the formulating of the ink when you are adding the graphite, it may become improved. So that's why we added the graphite. So maybe get a composites. So vehicle resins, right? Diacetone alcohol and a cellulose acetate, you can add properly, proper ratio. Then only you might be able to get to formulate the ink, right? Otherwise, we can't able to formulate the ink. And yeah, basically you can see that I'm going to switch on the video. So this is a formulating ink, what we have formulated the ink, right? The same ink only. Yeah, later when it's required, I'll switch on my video. So this is what the ink we are going to formulated, that the ink the same way what the earlier I have shown, right? Of course, it will come future also. Screen printing, we can able to do that. So active material, binder, and additives. So you may get the proper ink formulations. So once you did the proper ink formulations, and of course you got to check the surface tensions, viscosity, and as well as the density, and of course contact angle. How it going to contact the substrate. The contact angle is one of the important properties to optimize the formulations. Those are all the physical properties we will check that. So once if it is reaches proper formulations, particularly screen printing means we have certain range of the viscosity. That viscosity, if it is able to reach only, we can able to go for printing. Otherwise, our mesh is waste and we can't, it may not pass through the mesh. That entire mesh, it will be gone. We can't able to do the devices. So this is what the same method what we have shown in the supercapacitor, the same method only we are preparing. But in addition, there we going to use a electrolyte, but here we are not going to use a electrolyte. Okay, and this is what the ink formulations. Organic vehicle was prepared in diacetone alcohol. This is what we have synthesized a material it called as organic vehicle. In that, you have to add a cellulose acetate propionate, and what if you added the tungsten oxide graphite based ink, finally you might be get. And how we can check that? So basically, when you are varying the inorganic salt, different, you see that here you can find out the lithium chloride, potassium acetate, magnesium chloride, like that we have varied. So when you prepare these saturated solutions, the relative humidity, it might be varied to 11 percentage to 97 percentage. So when we are keeping this sensor and we can calibrate with the we can purchase this kind of humidity sensor in Amazon, and the same our sensor every time it has to be calibrated with the commercial device because the resistance it's varying. We can optimize that. In addition to that, what we can prepare the salt solutions, whether giving 10 percentage or 23 percentage, we can check with the commercial humidity sensor because that is very important. You have prepared the salt solutions, it doesn't show the 33 percentage, the entire work it might be vain. So what it do, commercially we have purchase a humidity sensor, we can check that our salt solutions, whether it's coming a 11%, 23%. Then with respect to what is the resistance is changing, everything we can able to monitor that. And with respect to that, we can able to so this is basically salt solutions. Imagine that now I can remove all the salt solutions. You are giving one agriculture product. Suppose the agriculture product is showing a 10% humidity. Instead of salt solutions, you can keep it our sensor. It will show a corresponding resistance. Accordingly, resistance it will map with a microcontroller, microprocessor. What is the relative humidity? It will show that. So basically, you can able to control your agriculture product. So this much humidity you have to maintain. Then only the product it may comes a long time or not. So that's what you have to do that. And of course, in addition to that, now recently we have submitted one more proposal in small ICMR grant. The basically our sensor in the breathing, it might be a moisture will be there. So whether the patient able to breathe it properly or not, whether he's doing a normal breathing, of course, that can be monitored by the observation itself. But suppose one cancer patient is there, right? He is able to breathing when he able to toxic gas when he able to breathing, he can able to deliver that. So that's what we are mapping with that. So this sensor, it has been mapped with the gas sensor and what kind of unwanted toxic gases it's going to produce, right? That also we are matching with the device and we are going to map with our devices. And of course, now basically we are concentrating on the ammonia concentrations with that ammonia concentration because if you go to fish industries, right, toxic gas it might be produced. So when the toxic gas is going to produce, no one can came to know that. So due to unwanted toxic gas, that those who are operating in the industries, they are facing a huge problems. So they have requested, is it possible to monitor the toxic gas using your sensor? That also we are working in that in the flexible method only. And comparisons, these are the different components we can able to find out. And of course, we are working on the gas sensor, temperature sensor, and a pressure sensor. And basically, we are synthesizing the material, formulating the ink. After formulating the ink, we are checking the physical property of the ink, whether formulations has been proper or not. Once we verify only, we are printing. So industry applications, gas sensor is required, LPG, CNG leakage detection, and the temperature sensor, you might be new the thermometer, and the touch sensor, pressure sensor, and human pulse monitoring system, and smart packaging of a perishable. But if you see that DMart under, if you see that, if you went, you can come to find out, they might be put the proper humidity and the temperature also. That under based on the flexible substrate only. So we can able to do those things also. And this is what we have nearly some 3 to 4 patterns we have developed in the particularly ink formulations materials. And now we have the strong concept of how we can prepare the conductive ink used on the carbon-based material. And of course, using inorganic material and the conducting polymers and the 2D material, MXine, molybdenum sulfate, tungsten sulfate. This all the method we can ready-made inks are available. Using that ink directly you can print and you can be able to develop the sensor. And of course now we are in next stage to fabricate our device also. And all the method we are doing screen printing. So these are the devices available: supercapacitor, humidity sensor, temperature sensor, gas sensor, pressure sensor. Anything we can able to develop as per the customer requirement. And of course, the inset work it is done by these two students. And of course, printing progress, it's Professor Ramakrishna Naik is concentrating. The first pattern it has developed from them. And this is what we have tested the device. And this device, it's controllable by the smartphone itself. And this is a rheology properties. And of course, one more student, he formulate the ink. Everything he did instead of flexible PET substrate, In paper substrate itself, he can able to develop the device micro supercapacitor and did. And this is a formulating of the ink. You can see that. Yeah. This much dispersion should be required. This much viscosity is able to require. And of course, you have to achieve the conductive. So all the things, if you achieve only, finally you can able to go for printed. Once you printed only, then you can come for the fabricating the device and checking the device. Okay. And next one is not only this one. And next method, we have developed the battery bank for using 3D printing. The student has been developed because paper-based device, it shows a very low efficiency. To improve the efficiency, what we did using polylactic acid in our own workshop, right? MIT workshop, we have developed a flexible power bank. So in this 100 device, 100 device of the supercapacitor, you can connect the series and parallel. So as per your requirement of the power, we can able to give a battery bank also. And this is what I told you, this patent also last year we have appraised, we have filed the patent. The entire device, even humidity sensor also, we can do it in a paper substrate, right? And this is okay, this is not required. And I would like to show some of our products. And after that, I'll come for the question and answer sections. So basically, you can see that the first device. So this is what, right? Are you able to see? This is what the paper-based supercapacitor. So you can connect. So you see that two different surfaces there, right? Now I am going to connect, right? So you can connect, get a current connector. So here, if you connect it, you can able to find the device properly. And this is what the Yeah, this is what the humidity sensor. You see that here silver ink is there. Over the silver ink, we have pasted our ink and connector is there. And this is the first device what we have, including the electrolyte. You see that the device is covered this because over the substrate we have kept the electrolyte and the current connector is there. And without fabricating, you can see the device, right? Here you can see that silver ink will be there. Over the silver ink, what we have formulated the ink, it is there in the black color. Yeah. And the next one is, this is what we have fabricated the device. You can able to find out the humidity. So if you see the container here, right? So your agriculture product, you can keep it here. So with respect to when you are keeping your agriculture product, here you can see the display. In the display, you can find out what is the humidity of your agriculture product, right? So this entire device using electronics for you, one diploma student, polytechnic student, as with the help of polytechnic student and my research scholar, we developed the entire device, and this device ready for commercializations. Of course, don't ask the cost. Now we have spent nearly 2,000 rupees. And in market, there are humidity sensor using 250 rupees also it's available. But here the idea is the first device we have achieved that, and you can able to find out for the agriculture product. Later we can reduce the money for this device. And of course, there are some issues out there in the printing method, and to particularly the uniformity of the device we can't able to achieve properly. So to achieve that, we have did in the PVD and the lithographic method, and that method also we can able to find out. You see the proper, there will be no gap at all, and proper. This is what the next work we are going to do using lithographically. We are going to printed the device because all the commercially based device now we have cut down and open and see that everything they are keeping in a lithographic based printed device only. So we are going to commercialize the device, the next one using this aspect also. Okay. So this is what that's what my presentations. Now it's open to audience. If you have any questions, you can ask me. Mithul, it's over to you.
Yes, sir. The floor is open to questions. If anyone have any questions, please do ask, sir. Yeah, Surat, you can go.
Hello, good evening to all. I'm sorry if you hear some noise. I'm a little outside, but I was listening to the presentation. Sir, I had a very basic question.
Yeah,
So I would like to know, you mentioned graphene and zinc oxide as two conductive nanomaterials that are highly used in ink formulation for the storage applications for energy. Sir,
yeah.
what what makes these two materials suitable rather than any other alternative that is present today?
No, see, basically, there are the material should be conductive one, right? How you are going to, because sensor means it's a resistance-based sensor. In the resistance-based sensor, we got to achieve the good conductive. Then only when the whatever either it might be a gas variations or humidity variation, the resistance has to be varied. So basically, we are working out the material whether it's a conductive or not. Not only we are working for the sensor, whether we can able
Hey,
to
meeting.
whether
Hello,
we can
meeting.
able to prepare for the energy storage device also. So for that reasons, the material if it is a conductive, even if it is not first you are synthesizing, say for example, even good conductive material when you are synthesizing in the lab, the first time preparations are synthesizing the material, the liquid conductivity can't able to reach. So you got to tune your material and finally you might be get the proper conductivity of your substances. So basically, how you are going to achieve your conductive, that is the first preliminary. You can synthesize any kind of material, doesn't matter. But how you are going to achieve the conductivity, it's matter for these kind of devices. I hope I answer your questions.
Sir, so would the chemistry of the material, let's say the structural molecules and structure of the material would not hinder the process?
Yeah, definitely. Of course, to improve the conductivity, there are two kind of mechanisms involved in that. One is growth stoke mechanism and another one is ion conduction mechanisms. So whenever the ion is going to move in this substrate, then only the conductivity is going to improve. Or whenever the covalent bond, it's when you are doping the material, when the ion is carrying, it has to form a covalent bond with the ion. Then only the conductivity it has to be increased. So basically, with respect to two mechanisms only, the conductivity of the material it's going to increase. So you got to play with that. How you are going to achieve that?
So, sir, what in this situation? A last question, sorry. What would
Yeah.
you prefer in this situation? A monovalent or divalent doping?
Now we are doping with, say for example, conducting polymer means we are doping with the respective acids only. Sulfuric acid means it's a divalent. Suppose if you go for inorganic materials, right? Now we are working on the surfactant. Surfactant may not helpful, but basically you can do nitrogen doping and inert atmosphere when you are doping the gases in the inorganic material, the conductivity may improve. And of course, semiconductor means you might be studied that, right? Barium doping or the molybdenum doping. Those things also you can do that.
Thank you, sir.
Yeah.
We have another question from Santushti.
Yes. Good evening, sir. Thank you for your
Good.
presentation.
Yeah.
Uh, I wanted to ask, sir, we can see that in the industries right now, there is an increasing demand for flexible and variable energy storage devices. How would you say that does the ink formulation need to adapt to meet the specific requirements for these applications?
Yeah. See, I'd like to give one example. When first the student is joined, he has joined and prepare the one ink material and one flexible substrate. And that time one vendor came for the industries. After seeing that, the 1 month only over that student. Immediately they want, can you join in our industries? They have asked. So that much job opportunity is there in particularly in flexible substrate and formulating the conductive ink. And of course, that formulating the conductive ink, right? Basically, it's a trial and error method, right? Today, for particular in our lab, might have the compound might have one assay will be there, right? So that assay, we might be use a trial and error method. We might be reach a proper formulations and we have printed and we got a conductivity. Tomorrow, if you go and did in some other lab, if you did the same formulations, it won't work. So if you come to the lab, right? What kind of, so where you have purchased the chemical, suppose if you purchase the chemical in a robot chemical, the same chemical only you have to use, the same formulations you have to use. Then only you can able to achieve the formulating the ink. So you purchase a robot chemical, but you went for the some other chemical, Tata chemical, you purchase a chemical. Then if you formulate the ink, it never ever match because the robot chemical normally they used to sell the chemical low quality. So that means basically what I want to say that suppose if you are preparing the ink, right? If you are formulating, this is a formulations I have given. What kind of chemical I have purchased, where I have purchased, everything I have to address that. Then only, even if I commercialize and if I give my technology to the vendor, he can able to prepare the same formulations. Any one parameter will affect the formulations. So basically, trial and error method, how you are going to achieve the viscosity, surface tension, contact angle, density, those things is very, very important parameter. Then only you can formulate the ink.
Yes, sir. Thank you, sir.
Yeah. Yeah.
Are there any other questions? So I have a question for you. So what are
Yeah.
some of the potential health and safety concerns which will be associated with using nanomaterials in production?
So basically, the inorganic materials, what kind of material you are using, and organic material means all the materials are carcinogenic. So that means basically what kind of applications you are looking, right? And where you are keeping your sensor. Well, suppose you are vivo studies. If you are doing means it may you are keeping in inside the body. Definitely, it might be a carcinogenic. You go limited to use a certain type of materials. So, what kind of material where you are going to apply your sensor? It's matter. Based on that, you can select the material. Then you can formulate the ink and print it. Right. So, basically, suppose I am going to use for the breathing sensor, right? Breathing sensor, and I'm going to monitor the toxic gases. Where I'm going to keep it in the inside the nose means definitely it might be toxicity. So I'm going to keep it in the mask itself. So the mask inside the layer of the mask when I'm keeping, it won't the sensor, it may not going to touch the patients. So we can easily monitor. So basically, where you are going to keep your sensor, that is matter. Then you can suppose you are going to keep it inside the body, then you should be a proper, it should the material should not be a toxic one.
Okay, and so you mentioned about inkjet printing. So apart
Yeah.
from the limitations which are faced in nozzle size and the printing resolution, did you like come across any other challenges in using that technology?
Basically, up to now, last 2 years, we are failure to prepare the inkjet printing ink. The reason is whenever we are formulating the ink, when we keep it in the nozzle, the entire ink it's just fell down to the substrate. We can't able to get a proper pattern. Even if you get a proper pattern, might be one printing it's coming. When you go for the second devices, we can't able to achieve that. And even we purchase a commercial ink also, we couldn't able to achieve that. We are trying to address, but we don't know whether it succeed or not based on our trial and error method and how we are putting hard work. Basically, with respect to that only, we can able to tell. Right now, I don't have answer for that.
Okay, sir. And so one last question. This is like a very general question and not related
Yeah,
to the presentation. So
yeah.
what are some of the advices which you have for students who are seeking for research internship, and how do you think they can maximize their opportunities which are available?
Yeah, basically, see, I'll like to tell when I'm JR, junior research fellow in Central Electrochemical Research Institute, CSR Institute, they have the n number of department will be there, right? Particularly the BTech student, no? BTech Electrochemical Engineering is there. They used to come each and every department. Student used to come, and every department they will learn the techniques. And one or two department they used to publish a paper in BTech itself, third year and fourth year. And of course, they will concentrate on GRE and TOEFL. Even some student they will clear the GATE exam also. So if you have the two papers in the BTech, particularly the second year, it's a proper time. The reason is first year you might be higher secondary courses, you might be put a lot of effort, you might be tired, rest. So first year normally we won't concentrate, but second year onwards, if you concentrate, basically what type of higher studies you are looking for, that what kind of research I can take it for further my studies. So with respect to that, now all the things are available. If you search in a Google Scholar, concerned faculty, what kind of work he is doing, you can come to know that, and you can approach them. Definitely in the second year, if you approach, in the end of final year, you can able to every 6 months or every 3 months, if you concentrated continuously work, you can able to produce at least one manuscript. After 1 year you are working, you can't able to produce a manuscript. Either faculty is not good or you are not doing a proper report. That's what my advice. So if you get a proper paper, so that Achindi Aditya, no, one he got a fellowship in Japan and they give a travel fair and they got a full scholarship for MS and PhD. Like that, Achindi also, he went and worked in TAFR and he published there also 2D material and one nature material paper. Thereafter, he also got, he just BTech, right? Directly he registered for the BTech PhD and with respect to full scholarship fees. And he is look like a salaried fellow now. So very good, particularly higher studies is one of the good opportunity to improve your career. Now it is open to all, right? Imagine that in MIT, our department itself, we can able to develop the products and we can able to come with the device. We are very weak in technological aspect. If engineers he can come and help us like that to develop the device, we can able to do n number of device and we can able to do a n number of device in the market also. So basically, how you are going to approach a faculty, and of course, some hard work is required. Hard work means I am not telling from 9 to 12 o'clock you go to work in a day, some 1 hour if you spend the lab, but continuously all the days you got to come, what you are going to do, that if you properly monitor, definitely it's possible to take one paper in a 6 month. And of course, now you have the chat GPT. When I'm doing my PhD under, I got to wait for my boss to correct the paper, right? Whatever I am writing, he has to correct. Now that is also not there. Using ChatGPT, you can correct your entire letter, your manuscript, everything. You can able so you put the hard work for doing the lab trial and error method and did proper work. Able to get 3 months, you can able to get a paper. And imagine that MIT is supporting 30,000 for attending the conference. In addition to that, one paper, if you publish in a Q1 with respect to percentage, you'll get a 30,000. In addition to that, you can get a MTech with a full scholarship way. Right? You forgot if you don't want MIT, you can go for higher studies also. There are good opportunities are there if you publish a paper and clear the GRE and TOEFL.
Okay, sir.
Yeah. Yeah, I would like to show one of my research scholar, right? He only did Mr. Muhammad Saki, right? He only did the entire work. He is doing flexible substrate. He joined within a 1 month. He got a job opportunity in this field. Okay, so if you want to do any kind of work, you can approach us. We are ready to help you.
Sure, sir. I think
Yeah.
they will.
Yes, sir. Sir, one small doubt I had.
Yeah.
When you mention papers,
Yeah.
would you suggest someone start by writing a research paper or a review paper?
Basically, don't go for the review paper. because the review paper will helpful for the faculty. Research paper will helpful for the student. The reason is review paper will give a citation. The citation might helpful to get a faculty get a good citations, right? So instead of that, if you did a good research work, if you publish that, tomorrow you are facing the interview, you can show your research paper. This Sunday I have a skilled in that, right? Whereas review paper, it is so might be you might be good in communications, right? You might be good in writing, but whether your skilled is good, your skilled hands-on experience is good, hands-on right is different. I hope you might be understood what I'm going to tell.
Yes.
Yeah.
Thank you, sir. So I'll just wrap this up then. So thank you, everyone. As we draw this enlightening session to an end, I'm sure I speak for everyone over here in expressing our deepest gratitude to you, sir, for your invaluable contribution. Your expertise and wisdom will enrich in us understanding and inspiring us to explore new areas of research. So, on behalf of RSM, I extend my heartfelt thanks to you, our guest speaker, and to all of you for your active participation.
Yeah. Thank you for this opportunity and thank you all. Yeah, I'm leaving
Thank you,
now.
sir.
Thank you.
Okay, thank you, sir.
Thank you all
Everyone
for taking
can
part in Cognizance 2024.